allowing applications to talk to Java. Java talks to the operating system, and the operating system talks to the hardware. The benefit of this is that the programmer now doesn't have to write one version of his or her program for, say, a Windows platform and another version of the same application for, say, Mac or Linux or a mainframe. Java can kind of intermediate so that the same application can run on multiple platforms. So Java is written, different versions of Java are written to talk down to different operating systems, but they talk up, if you will, to the same applications that allow those applications to be run on multiple platforms. Now, let me speak for a moment about hardware for a moment, particularly hardware in desktop and tower computers, microcomputers. In my opinion, the essence of the box, the computer, is the motherboard. The processor, the memory, the cards, the DVD drives, everything either gets wired to or plugged into the motherboard. This is the motherboard of an older model personal computer. Let me draw attention to the battery, bottom right side of the picture. If you ever get a CMOS error on booting your computer, something about, memory is not correct, CMOS error, don't throw the computer away. Open the case or have someone open the case and replace that little battery. For some reason, that battery in some computers is necessary to hold some information that needs its power in order for that information to be held. Of course, the motherboard is inside the box, and there are peripheral devices either wired to the case, I should say, such as a mouse and a keyboard and so forth, or those peripheral devices, including printers and so forth, may be connected through wireless means to the case. That includes the motherboard and the processor and other aspects of the hardware of the computer. Now, I've tried to illustrate that the architecture of an individual computer can be thought of as being in layers, at least 3 layers: hardware, operating system, and applications. Let's now begin to think in terms of networks. A network is a group, 2 or more computers that talk to each other. And I like to visualize networks as having tiers as opposed to layers, although you can also think of networks as having layers also. A client-server computing system is based upon the idea that some of the machines, some of the computers on the network ask for things, ask for services, and other computers are specialized to provide services when they are asked for them. For example, a client computer might ask a printer server to print something because the actual printer is not attached to the client machine. The actual printer is attached to the print server. This allows many client machines to use the same computer or the same printer. Otherwise, if you had 100 employees and they each had a client computer on their desk in front of them, and they all sometimes needed to print things, you might have to buy 100 printers and maintain them. No, under client-server network computing, the client machine, when the human user says, I want to print something, the client machine can tell the printer server, this needs to be printed. The printer server sends information, data, to the printer that actually does the printing, and the printer says, okay, I did that, says that back to the server, and the server says that back to the client. This is good. It saves companies money. This is an example of client-server computing. Basically, client-server computer is where the client machine says, I need something, and the server says, okay, here it is. For example, there are application servers. Say that a company uses Microsoft Excel. It has 50 employees, 50 machines, client machines, and some of the employees need Excel at the same time. Well, the company could install Excel physically on those 50 machines and pay Microsoft Corporation for 50 licenses. And then every time they had to upgrade to the new version of Excel, physically touch 50 machines and do the upgrade. Well, there's a better way. On a local area network, there can be an application server. LAN is local area network. There can be an application server such that when Joe double-clicks on the Excel icon on his machine, which is a client machine, Excel does not load from the hard drive of that machine, but rather the request goes across the network to the server that says, okay, I have an available license of Excel. Here's Excel coming back across the network, and it appears on Joe's screen as if it had been loaded from Joe's machine, when in fact it was loaded from across the network onto Joe's machine. So the benefits here of client-server computing is that the application is not running on the operating system on Joe's machine, but Joe's machine is reaching out across the network. The application is being sent across the network. So if the organization that has 50 employees at most only uses 20 instances of Excel at a time, in other words, there's almost never a need for more than 20 employees to have Excel up and running simultaneously. What you do is you buy 20 licenses of Excel, put those licenses on the application server, rather than buying 50 licenses of Excel and putting one on every machine. And now when Excel is upgraded to the new version, all you have to do is upgrade the one on the application server, not the 50 copies of Excel on every machine. So it's better in multiple ways. Client-server computing is important and valuable. Okay, I said a moment ago that one way that networks are structured is into tiers. And I like to think of tiers as being not layers, but rather tiers.